Yes, welcome back to Easy Gates, Gate 22 Easy Solutions. Let us get into the next problem. Yes, this one from control systems. Okay, a numerical answer type problem. For 2 marks. Okay, this is a problem figure given. Such a problem already happened once in the instrumentation paper, I remember. This is based on steady state error analysis. There are two inputs. One is the input command, another one is the disturbance. And given the disturbance is u of t, it's a unit step input. And the problem is you need to find the error due to the disturbance input command. Sorry, disturbance, not a command, disturbance input. That's all. And given r of t equal to 0. So for the given disturbance, what is your error at steady state? That's a problem. So what is ESS due to your disturbance input? But the entire steady state error analysis, which you studied in control system, is belong to only the input command r of t. You never study steady state error analysis due to the disturbance. So it's a problem to begin from the scratch. But still it is answerable if you play at time t equal to infinity. That's your steady state error analysis. Straight away you can play any closed loop. You can play comfortably at steady state at time t equal to infinity, even if you have enough integrators. There is one integrator. This is that integrator given. There is one integrator, but your mind will say there is one integrator, step input, error can be 0. But that's a concept only for the input command, not for the disturbance. So that caution you need to apply because it's a numerical answer. A numerical answer, you should not feed the answer as by mistake 0. We'll see here also it may be 0, but I'm not sure. Okay, we'll find out that answer. How to play for this problem at time t equal to infinity, we'll see first. So that's a given block diagram. Let me draw the given block diagram with the given conditions. R is equal to 0. I'm playing straight away at time t equal to infinity at steady state. This is plus, this is the negative feedback, and here we have the gain of 10. Then the unit disturbance, unit step disturbance applied at time t equal to 0 second. This data is 1 even at time t equal to infinity, and this is plus. Then here, let me play carefully. Let me split this into two boxes. One is 1 by s. Another box, I will take it as 1 by s plus 10. So you will comfortably play with the available integrator. That's the beauty of the problem. This is what exactly expected from you when you have integrator in the loop. Okay, if you really studied control system well, this is how the problem has to be approached. Now you are playing at steady state. See, what you are skipping means you are not going by the formal way. You are going by the, what is the formal way? Final value theorem to find out the steady state error. What is the steady state value of this signal? That's a question. You need to find out only this. So for this, I'm not using the final value theorem. So trying to master the given closed loop control system for the disturbance input. I'm splitting the given system into two parts. One is the integrator belong to the system. Another part 1 by s plus 10 that resembles k by tau s plus 1. That means its k is equal to 0.1. Its static sensitivity is 0.1. Play with static sensitivity. What's the beauty of integrator? We have learned so many times when there is an integrator, if there is a step input, integrator comfortably will make its input 0. The point is this: whenever step input, when you have an integrator in the loop, it can comfortably make its input 0. That's what it does. That's a fundamental of integrator. Integrator, step input, it always tries to make its input 0. Yes, it is going to make it. It is going to succeed in this attempt at time t equal to infinity, not time t equal to 0. Suppose if we say time t equal to 0, it's only at time t equal to infinity. It can make its input 0. Okay. That's where you'll get the answer instantly. Yes, that you believe it. That is correct. what integrator is doing in the loop is it is an integrator. Definitely it is going to make its input 0 at time t equal to infinity. If you get this point, it's over. This is 0 means this is 1, even at time t equal to infinity. Therefore, to make the output of the summing point 0, no other way, it should be -1. So output of the block 10 is -1 means what's input of the block? -1 by 10. So it's going to be -0.1. Straight away, one can smartly feed the answer as -0.1 without any doubt. Without any doubt, straight away one can feed this answer. Yes, that's the beauty of this closed loop control system. Answer is -0.1. This is the smart route. If you ask me to play by the normal route, yes, for the practice you can do, but that is not the route for the examination. If this is not striking, that is a route. If this route is giving you the answer instantly, then you can get into the next problem, save enough time, and do one more problem or two more problem with the available time space. Okay. Yes, I'll show you once again how to approach the same problem by formal way. So we'll go by formal way. That's a final value theorem way. So let me take this as D of S. And this is my E of S. Formal way demands we don't have any steady state error fundamentals for the disturbance input. So we need to make it from the scratch. You need to find out E of S by D of S. Okay. Then we have to apply final value theorem for what? E of S. Then you will get ESS. That's your E of infinity. That's a way. Yes. So then start from D of S. So this is the forward path. This is how you can reach your E of S. R of t is already made 0. Then how many loops? Only one loop. We have loop 1. So one forward path. What is only? I'm visualizing the block diagram as an SFG. I'm going by the gain formula. What is P1? P1 is starting with this +1. So it is +1 into the transfer function 1 by S into S plus 10 into this also rapid. Okay. But still the last one is instantly giving you the answer. This will take a little more time. Okay. It's -1 into 10. Okay. But the first route you have to play very carefully. And this one blind route if that idea didn't strike. Okay. Yes. That's your first forward path. But 1 minute. Yes. I should go only up to what? E of S. So I have to stop here. That's my forward path. That is not going to cover 10. So that's your forward path P1. So P1 is going to be -1 by S into S plus 10. Then what's your loop gain? Loop 1. Loop 1, you are starting from the summing point. You travel by this and then travel to till the summing point means L1 will be so 1 by S into 1 by S plus 10 into where you are entering -1, entering -1, then 10 entering +1. So the loop 1, only one loop is available. So -10 by S into S plus 10 will be the loop gain. What about delta 1? Delta 1 as per the gain formula will be 1 because the available only available loop is covered by the first forward path. So delta 1 is equal to 1. Then get your transfer function. Yes, what is that? E of S by D of S is equal to what? P1 delta 1 by delta. What is P1? -1 by S into S plus 10. Let me check. Yes. Then delta 1 is 1 into 1 divided by 1 minus L1. So it's going to be 1 plus, what is that loop? It's 1 minus L1. So the minus will get cancelled. So 10 by S into S plus 10 you will get. Then taking LCM, you'll end up with -1 by S into S plus 10 plus 10 will be the transfer function. Then get E of S that is equal to -1 by S into S plus 10 plus 10 into D of S. Then substitute D of S. It's a unit step input. Therefore, D of S will be 1 by S. Substitute 1 by S. So now you are ready for the final value. Apply final value theorem. So multiply by S. Multiply by S. let the limit s tends to 0. Let the limit s tends to 0 on both sides. Resultant is e of infinity. Okay, yes. Now this s and s will get cancelled. Safely you can apply s equal to 0. The first term will vanish. You'll end up with minus 1 by 10. Then minus 0.1 will be the answer. And this is probably the route majority of the GATE aspirants might have taken, but the one who practiced well definitely skipped the second route and might have done the problem with the first route. Those who have attempted the problem with the first route, within few seconds, moment you get that idea of integrator will make its input 0, instantly you have the error. This is what the designer probably expecting from you. Okay, as a very good GATE aspirant, you should strike the problem, you should connect the problem with this fundamental, then you have learned your control systems better. That's what it means. Okay, yes, that's a way, and hope you enjoyed this content. Thanks for watching. Do subscribe our channel. We'll update you with one more video soon.